Hello, my amazing Algebra 1 students. This is Mrs. A, and I love math. And today we are here talking more on rational equations. We're on lesson 103, clicking down the lessons till the end of the book. And when we're talking about rational equations, we've already talked about them a little bit, but now we're going to talk about how to solve them as they get a little bit more complicated. And the method that we're going to use is we're going to multiply both sides of the equation, that should be an L, shouldn't it, by the LCD, or the least common denominator. And this is a very useful method because once we figure out the least common denominator, what it is, every single one of those denominators will go into the least common denominator. So when we multiply both sides of the equation with that least common denominator, then all of a sudden, once we cancel things out that can cancel, we don't have any denominators left at all. And it becomes very simple to solve for our unknown variable. So on this one, we're going to first build the least common denominator. And to build the least common denominator, what I do is factor every denominator as far down as I can. So 2 is already just 2 times 1. We don't worry about 1 being a factor, so that's already prime. We're going to multiply this, break this one down into 2 times 2 or 2 squared, either one, and then 2 times 3. Okay, so then I look at all of these denominators and I build my least common denominator. And to build it, I have to make sure that every denominator that I have will be represented in this least common denominator. So 2 must be in the least common denominator. 2 squared must also be represented. And I already have a 2, so I'm just going to multiply by another 2 to get 2 squared. And then 2 times 3. Well, we already have a 2, and they can share. So we already have a 2, we just need a 3. We only need to put in what is not already represented. Now, this one's a pretty easy one because you could look at 2 and 4 and 6, and you could say, oh, I know. The least common denominator is 12, right? Because you could do that pretty much without doing all of the math. You could say, okay, yeah, they all go into 12. But this verifies it. 2 times 2 times 3 is 12. Okay, and that is the least common denominator that will work. So now what we're going to do is we're going to take 12 and we're going to multiply it all the way across both sides of the equation. So I'm just going to do it like this so I can show that 12 is going all the way across. Okay, so 12 times y over 2. The 2 is going to cancel with the 12, leaving a 6y. Plus, now in the denominator I have a 4. 12 times 1/4 is 3. So we put the 3. 12 times y divided by 6. The 12 and the 6 will divide, giving a 2y. Now look at what we have there. We don't have any denominators at all, and we multiplied both sides by a constant number. No problem. Okay, and the big thing is that you multiply both sides by a non-zero number, and we don't have any problem. We know that 12 is a non-zero number, so there's no question. All right, so now I'm going to subtract a 6y from both sides to get all my y's on one side. So minus 6y, minus 6y, and once I do that, that will cancel. And I will get 3 equals negative 4y. 3 equals negative 4y. Now I'm going to divide both sides by negative 4. And I get y is negative 3/4. y is negative 3/4. Now, if you wanted to verify that that was so, you could put negative 3/4 here and negative 3/4 here and check it to make sure that you actually did get the right answer. But you did. All right, it's all good. Okay, so here is another little example. And we should put our sharp eyes on when something like this happens. We need to always watch out when multiplying by variables. We always must check. Now, it is still going to be the correct way to solve it. Some problems just don't have a solution, but this is still the right way to do it. We just always must check. In other words, when we multiplied by 12 on both sides, we knew that we had multiplied by a constant that was not 0. But when we multiply by a variable, everything can come out all right and it can look like we have an answer. But we don't know that that original variable that we multiplied by was not 0. So we must check anytime we multiply by a variable least common denominator. So we're going to go through the same process. We are going to look and say, well, there's a t in the denominator, a 3t, and a 3. So when I'm building the least common denominator, I need a t. I need a 3t, but I already have a t, so I just need a 3. And I need a 3, but I already have a 3. So my least common denominator is 3t. So now I'm going to multiply both sides by 3t. I'll multiply this side by 3t and multiply all the way across. I could put a 3t over here, but I'm just showing you I'm multiplying the whole thing across. So the 3t and the t will cancel with just a 3. The 3 will distribute to the t minus 2. So 3 times t is 3t minus 6 equals 3t divided by 3t. It's going to cancel. It's going to equal a 14 minus 3t and then times a negative 1/3. The 3's are going to cancel and we'll get a minus t. Okay, so now we're going to look again. So we're going to add a t to both sides to get all of our t's in one spot. And that will give us a 4t on the left. Now I'm going to add a 6 to both sides. And that's going to cancel that one and give me a 20 over there. And then that t is going to cancel. Okay, so I have a 4t equals 20, which gives me a solution of 5. So t is equal to 5. Okay, now let's plug in that answer. Now our t did not wind up to be a 0, so it should be a correct answer, right? We did not multiply. We multiplied by 3t, which in this case is 15, so everything should be good. Let's check it. If we plug in a 5 here, we get 5 minus 2 is 3 over 5, so we get 3/5 equal. Now the 5 here is going to be 15, 14 over 15 minus 1/3. Now I'm going to go ahead, just because I'm out of board, I'm going to change 1/3 to a denominator of 15. So I'm going to multiply the top and the bottom by 5. So I'm going to get minus 5/15, which we know is 1/3. All right, so we get 3/5 is 14 minus 5 is 9. 9 over 15 is 3/5. Therefore, we have verified our solution is t equals 5. Now this one worked because it turned out that we did not multiply inadvertently by 0. We multiplied by 15, which was 3t, and 15 is a non-zero number. So it worked. Here is example 3. And we're going to first build our least common denominator. So we're going to say LCD must have an n plus 2 and must have a 5. Now, there are two ways to work this one, and I'm going to show you the other way in a minute also. We're going to use the least common denominator method. So now this is my LCD. I'm going to multiply both sides of the equation by 5 times n plus 2. So I'm going to try to write it real small. 5 times n plus 2, which is going to go all the way across. So let's do that. 5 times n plus 2 is going to cancel the n plus 2 with just a 5 left. Okay, so 5 times n is 5n minus. Now, when we multiply the 5 times n plus 2 and we have the 5 on the denominator, the 5s will cancel. And I'll have minus 3 times n plus 2. Now, when I multiply that by 0, I still have 0. So now I'm going to simplify this. 5n minus 3 times n, I'm distributing, minus 3 times 2 equals 0. So I get 2n minus 6 equals 0, or 2n equals 6 when I add the 6 to both sides. And if I divide both the left and the right by 2, I get n equals 3. And that is the correct answer. We wound up with a non-zero constant number, so we know that it should be right. Now, if we plug in a 3 here and a 3 plus 2 here, we do get 3/5 minus 3/5 is 0. So it's very easy to check that one. Now, I'm going to show you another way to solve the same problem. Okay, we're going to turn this equation, since there's a 0 on one side, this can easily be turned into a proportion. Remember, our answer was n equals 3. So now I'm just going to add the 3/5 to both sides. And that's going to leave me with n over n plus 2 equals 3 over 5. And now I'm going to cross multiply. N times 5 is 5n. 3 times n plus 2 is going to be 3n plus 6. And I'm going to subtract the 3n. And I'm going to get 2n equals 6, or n equals 3, which is what I had before, but the proportion method does tend to be a little bit quicker than the least common denominator method, but we do get the same answer both ways. So they're both legitimate ways to solve. All right, so here we have another one that we could turn into a proportion problem very easily. We could add this term to both sides and we could wind up cross multiplying. But since this lesson is about least common denominator, we're going to keep on doing it that way. So we're going to build our LCD. We need a 3n, and we also need an n plus 4. Notice the n plus 4 and the 3n don't share any factors, so we just have to multiply the n plus 4n. So this is my least common denominator. So I'm going to multiply all the way across by 3n times n plus 4. And that's going to go all the way across this whole, both sides of the equation. So now the 3n and the 3n will cancel, and the 2 will be multiplied by the n plus 4, and I'll get 2n plus 8 minus. Now the n plus 4 and the n plus 4 will cancel, leaving me with a 3n times the negative 2, which would be a negative 6n, equals 3n times n plus 4 times 0, which is still 0. So 2n minus 6n is negative 4n plus 8 equals 0. And I can, because this is already negative, I can throw it on the other side. So I get 8 is 4n by adding 4n to both sides. And then if I divide by 4 on both sides, I get 2 equals n. And it is not a 0, therefore it should have worked, but we can plug it in. So we get 2 and 2 are going to cancel, so we're going to get 1/3 minus 2 here is going to make that a 2/6 is 0. And since 2/6 is the same thing as 1/3, you can see that that one is true. Okay, so this is example number 5. We're going to multiply by the LCD, which needs an x. And remember, x is not a factor of x minus 2. I have to be able to multiply two things together to get this for it to be a factor. So x times x minus 2. That's the smallest we can get, that least common denominator. So we're going to multiply all the way across by x times x minus 2. Okay, so the x and the x will cancel, so that'll be 4 times x minus 2 will be 4x minus 8 minus, now the x minus 2 will cancel, leaving the x times the 7, 7x. Everything's going to go out because of the 0. 4x minus 7x is minus 3x. Minus 8 equals 0. Minus 3x, so I'm going to put minus 3x equals 8 by adding the 8 to both sides. Divide by -3, divide by -3 to get the x by itself, and x is -8/3. And x is -8/3 is the answer. And we have one more example and then some practice problems. Okay, last example. We have a p and a p minus 4. The least common denominator will be p times p minus 4. So now we're going to multiply all the way across this whole equation. The p's will cancel on the first go around. P minus 4 times p is 4p minus 16 minus p minus 4 will cancel. P times 3 is 3p. The 0 is going to knock everything out of there, and we get a 0. 4p minus 3p is just a p minus 16 is 0. P equals 16 when I add 16 to both sides. P equals 16. Here's a practice problem for you, so copy it down. Everybody copy it down and then pause your video. You remember you're going to build your LCD. Our LCD needs a t, and our LCD also needs a t minus 3. Since they have no factors in common, we will multiply the two of them together. So now we're going to multiply this whole thing by t times t minus 3 to the numerator. If you want to, you can throw a 1 down there. Just to remember that this is multiplying across the numerator. The t and the t will cancel, leaving a t minus 3 times 5 is 5t minus 15. Now the t minus 3's will cancel, and I'll get a minus 2t equals 0 times anything is 0. So 5t minus 2t is 3t minus 15 is 0. I'm going to add a 15 to both sides. Oops, add a 15 to both sides. And I'm going to get 3t equals 15, or t equals 5. Now, I haven't gone back and done it for each one, but if you plug in a 5 there, that becomes a 1. If you plug in a 5 here, that becomes a 2 minus 2 over 2 is also 1, and 1 minus 1 is 0. Did you get it right? Hopefully you did. Here comes the last practice problem. All right, everybody, last practice problem. The least common denominator needs a y, and it also needs a y minus 3. Since they have no factors in common, we have to multiply them together. We're going to put our little parentheses showing multiplication. Y times y minus 3 over 1, all the way across the top. Y, oops, I erased it. Y will cancel the y, and 8 times y minus 3 is 8y minus 24. The y minus 3's will cancel, and I'll get a 5y. And 0 times anything is 0. 8y plus 5y is 13y. And then minus 24 is 0. And then 13y, we're going to add a 24 to both sides. 13y is 24. Now that's not going to turn out very pretty. It would be much nicer if it was 12y, but it's not. So we're going to divide both sides by 13, and we're going to get y is 24/13. Okay, now that one looks kind of crazy, but it is the correct answer, and you can verify that if you plug in a 25/4 on the bottom, 24/13, then the 8 and the 24 are going to cancel with the 3 on the bottom, and the 13 is going to swing upstairs. So we're going to get 13/3 plus, now we're going to put 24/13 down here, 24/13 minus. Now, I need a common denominator to make this make sense. So 3 times 13 is 39. So that's going to be 39/13. And then when I take 24 minus 39, I'm going to get minus 15/13 down here. And the 5 and the minus 15 is going to cancel with a negative 3/13 on the bottom. And when I divide by a fraction, I multiply by the reciprocal, and that's going to wind up being 13 over, what did I say that was? Negative 15, and that's going to cancel with a 3, but it's negative. So I end up with 13/3 minus plus a negative 13/3 is 0. Now I don't go check them on all of them, but that's one of those things that you would not intuitively have guessed that the answer was 24/13. So I went ahead and plugged it back in to show you that yes, indeed, the answer really is 24/13. So remember, when you divide by a fraction, you multiply by the reciprocal, don't you? And it all comes out. And wasn't that a fun section? You get to go do your homework, but we are done with lesson 103. This is Mrs. A, and may God bless your day.